Okay, good evening. Yep, it is day 70, 71, I think, of coding every day. Um, I do not have a webcam today, as you can see. I'm at my parents' house and didn't feel like setting up that phone camera system again. And I'm using my laptop as a side monitor, and I'm not giving you a side view of my busted ass fucking face. Um, so we're going no cam. Um, so don't have a lot of time today, so I don't think we'll get too much done. But there was just a couple things I wanted to go over, and then do like a leak code or two, and then wrap this up. Um, so a few things I wanted to go over were that I got the site deployed. If you watched last video, you can see that I was um when we were trying to build the front end on Netlify, it wasn't working. What I had to change was the build command. I had to do an npm run build, not an npm start, um, which I should have known because it's supposed to compile at the build folder, not the actual, entire. It's not going to run it like a local thing, so we had to do that. Um, so when I get back to the API key, I um, is in my local environment at my PC at my apartment. So I can't hook up the back end just yet, so I'm gonna have to wait until then, um, to get the environment variable. Um, but everything else is working. Um, I mean, just in terms of the front end, it's being hosted fine. Um, so yeah, there's that. I also purchased this. So so it's basically, you could think about it as just like a Raspberry Pi, except the CPU is a RISC-V. So RISC stands for Reduced Instruction Set, um, and so I don't know if it's RISC Instruction Set Computer or not compute chip, maybe. Anyways, it's one of those things. Actually, it's something, but it's just reduced instruction set. The other thing would be a CISC, which is a complex instruction set. The difference is one is doing simple instructions. So if you wanted to, let's say, um, I don't know, if there's something that just combines multiple simple instructions, there would already be a term that you can use, an instruction that you can use. But in here, if you want to do something that's a little more complex, you just have to use all of the simple instructions. So both have their advantages and disadvantages, but the main thing about this is that unlike ARM and x86, this actually is open source, so I can see the instruction set and the architecture. So this is what we're going to be building off of, and it already has memory that I can go on. It has a micro SD card for storage. It has um, it doesn't have Wi-Fi on it yet, but it does have um, Ethernet. Um, and then it just has some all right stuff. But the main thing is that, so the only thing this thing comes with, sort of like Raspberry Pi, is these kind of bare bones, like it's a motherboard, CPU chip, memory, and stuff like that. But you give it power and you turn it on, and nothing's gonna happen because the only thing on this is the instruction set, and it's gonna look into all memory kind of reserves to look if there's some type of bootloader. And so then we're gonna start from there. So maybe one day I'll design my own CPU and architecture. Um, for now, we are just going to be starting from like a bootloader and going up and making an operating system. So I'll be doing that, and then we also on the side have to be working on my computer architecture project. Um, so I was talking with ChatGPT about it, and so the actual outline um, is I need to make an instruction set. and then make a CPU simulator to run the instruction set given um, it just given like a program. So if we have a program that is doing in binary, like say matrix multiplication or sorting algorithm or something like that, it needs to be able to take in that code and in the CPU simulator, and then it'll show us kind of everything that's happening. So the big part right now is actually designing what is the architecture going to look like, um, just what does that look like? Then we have to do an assembler. Um, I don't think it's needed, but a disassembler so we can see what's happening at the instruction level. Um, and then cache pipeline, stuff like that for the actual execution of this. So our instruction set, obviously how the CPU interprets and executes instructions. So we're gonna have to figure out what we're doing for registers, how many, what are they, um, what instructions, how we're formatting instructions, like how they're being read from binary to assembly, um, or what our instruction set is. Um, Addressing modes, I couldn't actually tell you off the top of the head. I mean, I'm guessing this is like direct, or pass through or stuff like that is kind of what it's talking about. Um, and then operations, this is kind of like with the simple, um, ISA is just like what does our arithmetic look like? What are we doing? Whatnot, what keywords do what. So, um, so I kind of went through and just wanted to see what this like may look like. So one is like an eight registers, with special registers for a program counter to know where we are. Um, Actually, no, this is the one for the address. The instruction register holds fast instruction, and then status register. I don't think I've worked with. Um, so I'll probably do that. Instruction formatted, so 16-bit instructions. So it's saying like one is add, and then this is this register, this register, this register. It just adds from those. Um, and then this is like a bit. I guess these ones are the ones that I need to look at a little more and kind of just what they're doing. Um, what instructions are supported? I mean, definitely we'll do add, subtract, and maybe just XOR. Um, Load and store, obviously we need. Um, Branching, and then we need a halt. So something like that. How do we access data? Pointer based memory. We'll probably do something like this. Actually, it might be better just to go all like do everything simple, and depending on the time that we have left at the end of the semester, like start upgrading some stuff. Um, so right now I have to work on, I think on the 24th, I have to present what we're going to be doing for our instruction set architecture. What it like looks like, what we're going to be dealing with, what we're including, stuff like that. So I'll have to work on this with my partner and just see what we want to do. Um, so yeah. So those were the two things that I kind of just wanted to discuss. Um, this is the actual like in-depth outline of what the project is. The simulator is another big part, which is will just act as like a CPU, like the pipelining of a CPU, and what would happen there. Um, memory stuff, a lot to do. It's definitely going to be quite the class um, and project. So yeah. Uh, um, I don't think there's anything else I want to talk about right now. Maybe we could just get into LeetCode. Hmm. I also got the Apple II monitor. So, oh yeah. Only other thing I wanted to talk about is so like yeah, this is gonna be the bootloader and whatnot. I'm also gonna have to write my graphics, like how that works. I'm pretty sure. Because this is a digital video port, but I'm guessing obviously that's for an operating system, right? The operating system looks for that port and it already has what is it, UFIE or something like that. Um, so we'll have to write our own UFIE or rip it, or we'll see. Um, because I want to make it custom to the Apple II monitor. Ah, let's see what this is. Given a binary array of nums, you should delete one element from it. Return the size of the longest non-empty subarray containing only ones in it. Return 0 if there's no such array. After deleting the number in position 2, there's 3. Okay. Um, huh. Alright, well, I think I'd want to go, but like in that first one, like let's say that other set of ones wasn't there. Let's say this one wasn't there, it'd be this one. So I was gonna say let's go until we see the first one, but that wouldn't make sense. Um, I mean, what you could do is, um, hmm, see, just the first one being like, so I guess I could say like, if the first one is not a one, like it would be like an edge case, right? Because otherwise, let's say if I just started counting ones, then I got to a zero, and I flipped the zero, and and then like, you know, huh? It was actually, it's the exact same of the other one, right? Like, is it not just this? So like, but instead of this, we just know that k is 1, right? But okay, let's go back and let's say, does this not just work? Uh, oh, this is deleting. This isn't, so if nums at end is equal to 0, if this, the decrease that, but also, I mean, is this not just going to be return max length minus 1? Just because we're deleting that, we just don't want to include it, right? Is it not just that? Okay, yeah, it is just that. It's literally the same concept of having a double pointer and a max length and saying while the end pointer is less than the array that we're traversing, if nums.end is equal to a 0, right? Um, so if the this pointer, if we're at something that isn't, here, I'll go to description, or if it is equal to this, right? So this would be the way where the pointer hits first. We say, okay, if k is greater than 0, which is at 1 on our first one, then decrement this, right? And then say max length is equal to between the max length, which here would just be 0, and then end minus start. So end is 2 minus start plus 1. Start would be, so it would be 1, right? Would it be 1? What would it be here? 2? Well, where's start? Start is at 0. I mean, is that not 2 minus 1? Wait, I'm kind of confused then. Oh. It's because we're doing, um, um, so we go through here, right? And this, the value is just 1, correct? So we skip this, and we just say max is the max between max length and end, which is 0 minus, um, now that's still weird. Why am I blanking on this right now? Then we increment end, right? Is end equal to 0? No. So we say max length between, it's just not 0 and 0. End is 1 minus 1, 0, 0. Go to the next one. If this is equal, so yep, it is. If k is greater than 0, which it is, so now k is 0. And then say max length is equal between, so this is now 1, incremented again. it's not this, so we go through again. And so is this 3 now? And then we increment it again. So would this not be returning 2? I mean, obviously it's not. Here, I want to do a print statement on this. I want to print end, or here I can just say, but I kind of want to know where I am, so I want this to be, uh, I just want to see what's printing with this. So we're at 0. So end 0. We go through, we say if end is this, which is not, we go through, and end minus start plus 1 is 1? How is that 1? What is just, give me start as well. What is this giving 1? Like I feel like it would be, you'd want to take this, right? Start plus 1 minus end. Oh my God. I knew it was some arithmetic shit. I knew it. That's how it's interpreting it. Okay, okay. This could make sense now. So it's end minus start plus 1. Now, why was I doing the plus 1 before? Does this mean that I can just do... Oh, let me do that. Does this mean I can do this? Okay. So why were we doing a plus 1 in the last one? The last one we were flipping. It was the max between the end minus the starting index. I mean, is it just a 0 offset, I'm guessing? That's usually what the plus 1s are here for, is to get this off a 0-based index. Hmm. Anyways, yeah, that works well. I mean, it's the exact same premise. The other one was you can flip two zeros. This one is just um it's just you remove one zero. So the max length wouldn't be um maybe it's plus one because of the flip. Maybe that's it, right? Because we're not actually flipping anything in here, so we're saying, okay, if, because um if k is smaller than this, then it means that we flipped. Or no, 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 no. It doesn't even matter if k. It just means that like, yeah, weird. It has to be something with that. I'm too tired to think about that right now. But yeah, it makes sense. 1 second. My dog's gonna bark again. Okay. Dog decided to go next to me. Okay, one more, then I'm gonna drive home. Oh, I have to submit it in that other mode, so it'll go to my GitHub. Hello, puppy. Beautiful. Hash map. Okay. Given two zero indexed integer arrays, my God. Nums one, nums two, return a list answer of size two, where answer zero is a list of all distinct integers in nums one. Okay. So this is one. So is this not just turning both of these? I mean, it's everything that's distinct in here. So it would be like, um, if I made a set of both of these. Oh no. I mean, the absolute most brute force way of doing this is just saying for each in nums one, if each if each is in nums two, um, uh, I mean, just don't do anything. So what do I want? Just continue. Else, um, we'll have an answer or what, right? Where's my bracket key? There it is. Else, answer, add zero, equals each. Oh, sorry. Answer, add zero dot append each. And then for each in nums two, oh, not on, in nums two. Yeah, I mean, just copy it. Whoa. For each in nums two, if each is in nums one, add it to that, and then return that. right? Or is that wrong? List index out of range. What? I need to initialize this list. Can you do? Nah, I need to do like. Why? Why? Oh, why did it append 3 and 3? Oh, because we want to turn these to sets. Is that why? We want to say set nums1 and set nums2. Is that what you want? Didn't make it into a set, did it? Nums1 equals nums2 equals sums2. Wait, I don't know if this is actually correct or not. Yippee. This could be a lot simpler. My dog is screaming at me. 1 second. Well, okay, so I don't know how you solve this with a hash map, to be honest. I mean, so it wants it to be all distinct integers in nums1 that are not in nums2, so turning them to a set, um, turning them to a set is definitely the easiest way to do that. Um, but I mean, using a hash map, it would be something like, yeah, I don't know. I'm actually curious what holy shit, that is disgusting. You can just say set1 minus set2, and it just works like that. Also, just so this like looks a little cleaner. Yeah, no, that's pretty disgusting. You, get me out of C++. I'm so stupid. If each not. Oh my god. I knew I was like just doing. I'm like, there's no way I have to do like a continue here. I'm actually just fucking cooked, aren't I? That is horrible. If each is not in that, then we'll append it. You're goddamn right, that's what we're gonna do. Yeah, this works, right? Invalid syntax if it's not int, right? We still have to do an in. Cha-ching. Okay. Let's submit this, and then I'll wrap up, and I'm gonna start driving back to my apartment. Come here. No. Good boy. Good boy. Okay. I want to go to GitHub. LeetCode. Look at that. Can't believe it's already been 2 weeks since I started doing this. Crazy. Crazy, crazy. What is my wow, look at that GitHub squares. Fucking you go through like 2023, not a lot. 2024, just towards the end. Now right there, doing great. Wow, what was I doing in 2022? Ooh, design flex. I want to get this to have some more low level stuff in it though. That's the goal of this year is more low level whatever. Um, Also, we'll initialize the repository for my operating system. I'm calling it SciOS for no reason. Um, okay. Well, I'll call it there. Um, yeah, I'll call it there. Tomorrow I want to work on getting this hooked up and doing some, not finishing touches, but some big features I want to work on. Maybe we'll touch upon another two leak codes and then a lot of architecture work tomorrow. And yeah, that's the plan. So, um, yeah, I'll see you tomorrow. Um, for day 72. Okay, take care. Bye.